This tutorial is about macros, functions, and events, the basic logical structures that you use for driving everything that happens in your game. The primary and most important one is events. This is the basic driver that is going to run all of your main blueprints. One, because you can do anything in an event. It doesn't have any restrictions on what can be put in it. And two, because events can be triggered by outside events. So for example, a keyboard input. Whenever the one key is pressed, this event gets triggered. Automatically is just built into the engine. So a lot of the things that you do are simply going to be driven by you calling on these native events within the engine that are going to drive whatever happens. So an event of something dying, an event of something colliding, an event of a key being pressed or a button on the joystick or whatever. And from that, your logic is going to flow. As far as what restrictions or differences there are between the various formats, you can have one logic input, one execution input, and one execution output from an event. Events can have multiple data inputs, but events don't have any data outputs. Events can be inherited. Events can be called from other blueprints. It can contain any type of node. There are no restrictions on the kinds of nodes you can have in it. Next, we have functions. Functions can again be inherited. They can be called by other blueprints. They have one execution input, one execution output. If you have a pure function, the executions are still there. If you go inside the function, the executions are still there. They're just not visible on the outside. So you just pass in your parameters and you take out your parameters. You can't have any delays, timelines, anything like that. Anything that's going to happen outside the current tick. You can't have any type of those nodes inside a function. A function happens within the current tick. You have impure functions, pure functions, and pure const functions. Although technically, in Unreal Engine, you can make an impure function const. Don't know why you would, but you can. It's a thing you can do. But there is no definition for it. While doing research for this, I looked up, because pure and const functions are not just a thing in Unreal Engine. They're not just a thing in C++. They're a thing in programming in general. And I found a lot of conflicting definitions, but the most consistent ones that I found is that a pure function is one that won't affect anything outside itself. So within the function, you can't change anything. You can't change the value of like a global variable or change the state of like, moving an actor, anything like that. You're not supposed to. Unreal Engine will let you do it. C++ will let you do it, but you're not supposed to. And for const, it's even more restrictive. In addition to not being able to change anything, a const function is not supposed to know anything that you don't pass to it in parameters. So it's not supposed to read any global variables or anything like that. It is supposed to only know what you tell it and nothing else. In addition to, like with pure function, not supposed to make any changes. The const checkbox actually physically does place a restriction on what nodes you can use inside the function. If I try to put a node in here that makes a change, for example, let's grab a setter for this variable, throw this in here, and I try and compile it, I get an error message. It will not allow you to put in any nodes that make any changes. Now, that being said, there are ways around it. You can simply pass a variable Go over here and we change this to pass by reference, then you can use nodes like, for example, if the variable that's being passed in here is, oops, wrong button. If the variable we pass in is an integer and we pass it by reference, we could then increment it. And that's allowed. And this increment is actually changing the variable because we're passing it by reference rather than just passing the value and then using a setter. You can get around that restriction. You're not supposed to, you shouldn't do it, but it is possible. So basically, the pure and pure const functions are meant to be like getters. They retrieve information, maybe perform a quick calculation on them, and then spit that result out. They're not supposed to affect anything outside themselves. An impure function can do whatever you want, make whatever changes you want. Another big difference between an impure function and a pure function is an impure function has execution nodes on it. It executes when the execution is triggered. Whereas with a pure function, it executes whenever this connecting output pin gets used. So if this is connected up to here, then whenever this runs, that's when this runs. Now, the reason why that's important is you know when this is going to run. You know exactly when this is going to run. It's only going to run when that execution pin goes off. And its output stays exactly the same, what's called caching. So if I reference this here, or if I reference this here, or if I reference this anywhere, the value of this is always going to be whatever it was set to when this execution pin got triggered. And it won't change unless this execution pin gets run again. Whereas with a pure function, this gets called anytime this output gets used. So if this is connected up here, and it's connected up in a bunch of other places, its value can be different in all those circumstances. It also means that depending on the setup, depending on what you're doing, this can result in a lot more work. So let's say you've got an on-tick event, and inside that on-tick event, you're doing a for loop where you're running through the elements of an array. And for each of the elements in the array, you're performing some calculation that uses this function. It's going to run the function for each iteration of that for loop on every tick. Whereas if you use an impure function, and the impure function is run outside the loop, outside the tick, to establish this value, then it just uses the value, the cached value. So all of the calculations that are going on inside the function don't repeat for every iteration of the loop and for every tick. So pure functions, the nodes are much smaller, they look much neater in your code, and they can be quite useful for retrieving information, but be aware that that information is updated every single time you ask for the information. Whereas this, it's only updated when you call the function, and unless you call the function again, that information stays exactly the same, and it's just a value that gets used by anywhere that it's connected to. So if you know the value is going to change and you need it to be constantly checked and recalculated to make sure that it's accurate, you're going to want to use a pure function. If you know the value is basically going to be unchanging, except in very specific circumstances where you would then trigger the function to update that value, then it is much more efficient to use this. You have greater freedom with the impure function because it's allowed to read from global variables and it's allowed to make changes to the game state. And again, you can break the rules. The rules aren't enforced in blueprints and in C++. So you can do pure and pure const functions and have it read from global variables when they're not supposed to, and you can have it make changes to game state when you're not supposed to. You can break whatever rules you want, but if your program is, or your code is going to be used in part of a team or at a company or whatever, you're going to get in a lot of trouble for that type of behavior. So it's a really bad habit to get into. So again, an impure function only gets executed when you call the execute pin. Its output values are cached. A pure function gets called every time the output value is accessed. And if it has multiple output pins, then each time any one of the output pins is accessed. So like if all of the output pins, if there were multiple output pins here, and they all went into this one event, then it's still only going to get called once, because a single event, a single occurrence, is calling on all of them simultaneously. So they just get processed once. But if it's plugged into, like the different outputs are plugged into a bunch of different places, then anytime any one of the outputs is referenced by any executing node, the entire function gets run again. A const function is just like a pure function in that it's not allowed to change anything, but a const function also is not supposed to read any global information. It should only take its inputs. Now, something else you'll notice is that with the impure function and with the const function, you have a target. And with the pure function, you don't. And from many discussions I've had with people in the various discords, as far as I can tell, nobody has, at least people can't come up with any consistent, verifiable reason for this. And so the best I can think of is just it's a bug in Unreal Engine. And maybe, like I'm running Unreal Engine 5.03. So maybe in other versions this doesn't exist. This can still be called from other blueprints. And when you call it in another blueprint, it will have that target. But in the local blueprint where the function is defined, the target pin is missing, which, I mean, it's fine. In the local blueprint, you don't need the target pin because the target is self. So it doesn't seem to cause any problems or anything. It's just a weird graphical glitch, I guess, where the target pin doesn't appear. But it does have a target pin when you call it from another blueprint. You can call it from other blueprints. It is inherited, has the same behaviors of any other kind of function. It's just within the local blueprint where it's defined, it's missing the target pin for whatever reason. Next, we have macros. Now, macros allow you to have like delay nodes and other nodes that operate outside the current tick, which is something you can't do in functions. You can do in events. You can't call macros from other blueprints. They're just to be used locally. And they're not inherited by child blueprints. Now, obviously, a way to use a macro in multiple blueprints is you put your macro in a macro library. And you can also create function libraries as well. I have a previous video on that subject. So there is a way for a macro to be usable in multiple blueprints, but a macro you create within a non-library blueprint, it's only usable within that itself, its own blueprint. That's it. Now, some advantages to using macros is macros can have multiple input and output execution pins. So branching logic can be done inside a macro. And like having the branch, like you can have branching logic obviously inside an event or a function, but the branch only operates internally within the event or within the function. Whereas with a macro, you can have the branch actually come out of your macro and flow into other things. Now, this isn't like an official thing or anything, but you can have a quote unquote pure macro. You can have a macro that doesn't have any input or output execution pins. And unlike pure functions, where inside it, it still has these virtual execution pins, which means you can put setters and other nodes that do change things, even though you're not allowed to, you can. With the quote unquote pure macro, it actually doesn't have internal execution pins. So none of those nodes are possible. So even though pure macros aren't a thing, when you create a macro this way, you actually cannot physically put in nodes that change values. So pure functions are a thing, but aren't enforced in Unreal Engine. Pure macros aren't a thing, but are enforced in Unreal Engine. I just thought that was kind of neat. Now, another way you can structure or organize code within a blueprint is to use collapsed graphs. Now, a collapsed graph is very similar in many respects to a macro in what you can do with it. You can have multiple output executions like branching logic and things like that. Another neat thing with the collapsed graphs is when you hover over them, you get a little picture of what's going on inside them, which you don't get with any of the other types. But the collapsed graph is strictly an organizational thing for just simplifying a complex event that you've got going on in your blueprint. The biggest drawback to collapsed graphs is they're not repeatable, reusable in any way, shape, or form. Like a macro, you can create a macro. Yes, it can't be inherited or called by other blueprints, but you can reuse the macro over and over and over again within this blueprint. A collapsed graph only works in the one spot where you made it, and that's it. So if you've got a bunch of complex spaghetti crap that's going on in a particular section of code, you want to simplify it down, you drop it down in a collapsed graph. So now it's just got a node where you can put in a customized name just to make things more readable. If you wanted to repeat or reuse that code anywhere else in your blueprint, you can't with a collapsed graph. You've got to use a macro. Well, I mean, obviously you use a function or something else, but if it's got delays and stuff in it, and you want branching logic coming out of it, and all the other fancy stuff that you can do with a macro, macros are your only choice because you don't have any kind of branching logic that's coming out of an event or out of a function. And functions can't have like delays or anything that moves outside of the current tick. So in those circumstances where you want the kind of things that you can do with a collapsed graph, but you want to use it more than once, then it has to be a macro. Something I want to mention here is a bug, I think, that happens, as far as I can tell, only with macros. When you want to pass by reference, pass a value by reference for an event or for a function or for a collapsed graph, all you have to do is for the particular variable, you just open up this little pull down arrow and check off pass by reference. But that isn't available with macros. When you look at the definition, there is simply default value, nothing else. So a way around that I found is for this one here, if I try and add a variable, it adds the variable not as a reference, and there is no option to have it as a reference. So what you can do is just grab yourself a node, like for example, the increment node, that accepts a reference as an input, drag that back, and it creates, as you can tell, the different shape. It's by reference. Also, when you hover over it, it says by reference, and this one doesn't. So you can get inputs by reference in a macro, but you can't define them over here as by reference. Like you can tell this one is by reference, but over here, there's no checkbox for that. So that's just a weird, I think it's a bug with macros. So if you run into that, that's a way you can force it to accept inputs by reference. Now I've got this chart that I quickly whipped up that just breaks down the basic differences between the different elements your macros, your functions, your events. I didn't bother putting in a column for collapsed graphs because a collapsed graph is basically, it's a macro that you can't use more than once. It's isolated to that one spot. So it's very restricted in what you can use it for. And in most circumstances, you're better off using a macro. And then the differences between pure, impure, and const functions. Hopefully I've covered everything. I've made several attempts at making this video and they end up rambling and go off on tangents. I forget things. I think I got everything this time. Hopefully. If I missed anything, feel free to ask down in the comments. Hopefully you guys found this helpful. Have a good one.